Number 1. Shale. As the most abundant sedimentary rock on the planet, shale is composed of incredibly fine-sized clay particles. It typically forms in very low-energy environments, like the bottom of deep lakes or the quiet parts of the ocean floor, where tiny particles have time to settle. You can identify it by its fissility, which is its tendency to split into thin, flat layers that look like a stack of dark crackers. Number 2. Sandstone. This rock is essentially a snapshot of an ancient beach or desert. It is made up of sand-sized grains, usually consisting of the mineral quartz, because it is durable enough to survive the weathering process. When you run your thumb across sandstone, it feels gritty and abrasive because the individual grains are still distinct, held together by a natural mineral cement like silica or calcium carbonate. Number 3. Siltstone sitting right between shale and sandstone. In terms of texture, siltstone is made of grains that are too small to see with the naked eye, but too large to be called clay. If you were to chew a tiny piece, not recommended, it would feel gritty against your teeth, whereas shale would feel smooth. It usually appears in thicker, less brittle blocks than shale. Number 4. Conglomerate. This rock looks like a natural piece of concrete. It is a mix of large, rounded pebbles and cobbles buried in a matrix of finer sand or silt. The rounded edges of the stones are a huge clue. They tell us that these rocks traveled a long way down a high-energy river, where the water tumbled and smoothed them over time before they were finally buried. Number 10. Chalk. This is a specific, soft variety of limestone. If you looked at chalk under a powerful microscope, you would see it is composed almost entirely of coccoliths, the tiny circular armor plates of microscopic algae. These tiny shells rained down onto the ocean floor for millions of years, creating massive white deposits like the famous cliffs you see in Europe. Number 5. Breccia. While it looks similar to a conglomerate, breccia is made of sharp, angular fragments rather than smooth ones. This tells a very different story. Because the edges are still jagged, we know the fragments didn't travel far from their source. Breccia often forms at the base of steep cliffs or along fault lines where rocks have been shattered and quickly cemented back together. Number 6. Limestone. This is a biological powerhouse. Most limestone forms in clear, warm, shallow marine waters from the accumulation of shell, coral, and algal debris. It is made of calcium carbonate, which makes it chemically reactive. If you're ever unsure if a rock is limestone, a drop of weak acid or even strong vinegar will make it fizz as it releases carbon dioxide. Number 7. Coal. Unlike most rocks made of minerals, coal is made of organic carbon. It began as dense layers of plant matter in ancient, stagnant swamps. Because the water lacked oxygen, the plants couldn't fully decay. Over millions of years, heat and pressure squeezed out the moisture and gases, leaving behind the concentrated energy source we use today. Number 8. Chert. This is a hard, dense rock made of microscopic crystals of silica. It can form chemically when silica-rich fluids move through limestone or biologically from the skeletons of tiny sea creatures like radiolaria. Because it breaks with a conchoidal fracture, meaning it curves like a seashell, it creates incredibly sharp edges. This is why it was the primary material for ancient tools and arrowheads. Number 9. Rock salt. Technically an evaporate, rock salt forms when a body of salt water, like a restricted sea or a salt lake, dries up. As the water disappears, the dissolved minerals become too concentrated to stay in liquid form and crystallize into solid layers. Large underground salt domes can be hundreds of feet thick, representing thousands of years of evaporation.